This video is to demonstrate how to do a chi-square calculation for a goodness of fit test using SPSS, and I will also show how to do this same calculation using R. The approach that I'm going to use in SPSS is not the most straightforward, and if anyone is familiar with another simpler approach, I would definitely be interested in knowing about it. So the problem that we're focusing on right now is we have a sample of 56 people who recently received speeding tickets. 35 were older than 25 years of age, and the other 21 were age 25 or younger. We're asked to conduct a chi-square test, and we're given the additional information that 80% of all licensed drivers are older than age 25. Now, in SPSS, I've already entered some of the information in advance. I've created two variables. The first is called age group, and the second is called frequency. Just really quickly, using the variable view, I'll show you that age group is actually coded as a nominal measure, and frequency is coded as a scale measure. I've entered the values 0 and 1 for age group. 0 represents, in this case, older than 25, and 1 represents 25 or younger. I've been told that there are 35 of the older than 25 individuals, and that there are 21 of the individuals that are 25 and younger. So the first thing in SPSS that I need to do is I actually need to engage the weighting feature. So I'm going to go to Data. I'm going to go to the last option, which is Weight Cases. I'm going to choose to weight cases, and I'll move the frequency into the frequency variable and click OK. Now SPSS tells me that it indeed is weighting the cases. Going back to the data set, I'm now actually ready to run the chi-square test. Under Analyze, I'll go to Nonparametric Tests, and I'm actually going to choose the legacy dialogues, and from here I'll choose the chi-square dialog box. I want to test age group, which I'll move to the test variable list. For the expected values, I need to change this to values where I'm going to indicate the value for each of the groups. So I know that it was 80% of the population is older than 25, and I have a sample of 56. So really quickly, I'll calculate that 56 times 0.8 is 44.8. So my expected value would be 44.8. I click Add to move that in, and then if this is going to add 56, I need 56 times 0.2, which is 11.2. I enter that as my second value, and 44.8 and 11.2 do indeed add to 56. So I can select OK, and this will run the chi-square test for me. So here it's reported the observed frequencies, which I knew in advance, the expected frequency, which was 44.8 and 11.2, calculates the residuals. From there, it calculates the chi-square test. This has 1 degree of freedom, and it gives the asymptotic significance. If I double-click on this table, I can double-click on the p-square value and obtain a more specific p-value, as this one's asking for accurate to 4 decimal places. This would be 0.0011 when rounded to 4 decimal places. Now, I also want to show this same calculation in R, as this is possibly a lot more straightforward. In R, I've already typed out the code here for the chi-square test. The first piece of information we enter in R is the two values for our observed frequencies, which is 35 and 21. And then I tell it what the probable values are. And in this case, R can accept entering the values as percentages, and I've entered them here as 0.8 and 0.2. When I run this test, it gives me the same values as I obtained in SPSS. And if I wish to see the expected values, I use the up arrow to generate the last code I entered. I'll add $EXP to produce the expected values, and notice it does indeed give the same expected values that I calculated by hand. I hope this was helpful. Thank you very much.